Next formula, which again should be familiar to you all, the slope or the gradient of a line. Several ways we can find it. I think probably the first way was using this sort of idea, vertical rise over horizontal run, and you looked at the pictures and worked out, oh, how far up did it go, how far across. So that was probably the first way you did it. Then we formalised it a bit more. Hang on, there's a number plane, there's our wonderful line. And we had a couple of points, we knew a couple of points on the line, and we came up with the formula. And said, oh, well, the vertical rise, well, that's just going to be the difference in the y values, and horizontal run, that's just going to be the difference in the x values. And so we had the second way of finding the slope. So let's actually do that. Oh, 5 minus 1 over 5 minus 2. Oh, 4/3. There you go. That's the slope of that one. There is, of course, a third way of finding it that is probably, well, the most easily forgotten way. We tend to forget this one, and that's if we know the angle that the line's making, we can use that. It's always the angle to the positive side, so we always go on the right hand side of the line to the x-axis, so in this case 120 degrees. And simply this slope is tan theta, but again it still comes from the idea vertical rise over horizontal run, because if you were to draw a right angled triangle, what you're really saying is opposite over adjacent. So that's how you get the tan. So for our blue line there, slope of tan theta would be, well, let's work it out, tan 120, 120, that's one of our exact values. Second quadrant, tan's negative, so it's the same as tan 60, which is, what was it? Root 3. So there we go, negative root 3. Of course, we could now go back if we wanted to and work out the angle that the red line makes. We worked out the slope was 4/3. We won't get an exact value, but if we wanted to work out that angle, we can say, oh, well, tan alpha, well, inverse tan 4/3, approximately 53 degrees. It makes that angle. No, I have not misspelt it. Two lines are parallel if they have the same slope. But the IFF means if and only if. What if and only if means is you can read this forwards and you can read it backwards. So it's true to say that if two lines are parallel if they have the same slope. So that means, well, if you know these two lines have the same slope, you can conclude they're parallel. But you can read it the other way. If you know two lines are parallel, you can conclude they have the same slope. You don't have to worry too much about that. I guess what we mainly need to remember, of course, is they have the same slope. So slope 1 would equal slope 2. And perpendicular if they are the negative inverse of each other. Or, I guess a more mathematical way of saying that is if you multiply the two slopes together, you get -1. Then the lines will be perpendicular. All right, here's it's actually a common sort of a question. So A, B, C and D, we've got 4 points there, but you'll notice the x-coordinate in the fourth one is missing. We've got to find the missing coordinate such that AB is parallel to CD. It's all right, AB is parallel to CD, so we know their slopes are equal. We can work out slope AB, it's 2. Slope CD would be 2 on A minus 3, but we can conclude, well, hang on, if they're parallel, their slopes are equal, so therefore we solve that little equation and we get that A is 4. Let's have a look at it such that AB is perpendicular to CD. In this case, the fact we know that they're perpendicular, so we can conclude that the slopes multiply together to give -1, and we've already worked out the slopes over here. So now solve this little equation and we get A is -1. Another, well, reasonably common question, this one. I've seen this crop up a lot. You've probably even seen it yourself. They love it. We've got 3 vertices of a parallelogram. We've got to find the fourth one. Now, some people try and do this without drawing a diagram. I think that's foolish. Because if you draw a diagram, it's a really easy question. So we plot A, B, C. Now, where do we place D to get a parallelogram? The naming of the parallelogram is important. So A, B, C, D. Where does D go? There's AB, There's BC. D's got to end up down here. So it goes A, B, C, D. Now, to find the coordinates of D, some people go a very long way about this. And what they'll do is they'll find the equation of the line CD. And they can do that because we know that the slope of CD is the same as the slope of AB. We have a point, we have a slope, we can work out the equation of the line. Hang on. Then they'll go and find the equation of the line AD. Then they'll go and solve them simultaneously, and you get the point of intersection. But that would be an incredibly long way about it. Because all we have to really use is the fact that those opposite sides are parallel. And I know to get from B to A, I've gone 3 to the right, 5 down. That's the slope. So therefore, to get from C to D, if they're parallel, I do exactly the same. So I'll go 3 to the right, 5 down. So therefore, I must be at the point 0 minus 10. There's my answer. Could have done the same thing by saying, well, to get from B to C, I'm going to go down. Now, how far down would I go? I'd go down 10 and then to the left 4. So therefore, to get from A to D, I'll go down 10 and to the left 4. And once again, you'd end up at 0, negative 10. That's why I say drawing a diagram. Whilst you think, oh, geez, I don't want to waste time drawing a diagram. But it's going to be quicker to draw a diagram than find the equation of those lines, solve them simultaneously, find the point of intersection. So actually, it's saving you time rather than costing you time. If you want to show 3 points are collinear, I think the easiest way is to do this. Pick a pair of the points. It doesn't matter which pair. I've gone A and B. Find the slope of AB. Pick another pair, AC, and then if those slopes are equal, one or two things must be true. See, because if they're equal, we're saying they're parallel. But in this case, they have a common point. So because they have a common point, they can't be parallel, so they must be the same line. So I think that's probably the quickest way of showing 3 points are collinear.